this is the M beam. Looking in here we can see two sections, two pieces of steel that are welded onto the bottom half of the pressing. This is the bottom half of the pressing. They're welded onto the bottom half of the pressing before the two pressings are welded together. There's the front or the rear half. As you look at the beam, this is the front, and this is the rear of the beam. As you look at the rear of the beam, there's this section here, and on the front of the beam there's this section here. Now I've got to decide, can I replicate that in any way on a standard beam that has no reinforcement inside it? I've had to think about it. Right, what I'm going to do, their solution's very, very neat, but I can't replicate it. I think the solution is to add extra steel along here, along here, along here, and along here. This is how I think the rear beam is acting when we load it. We've got 1500 Newton meters on the M, 1500 Newton meters coming through the prop shaft. First gear, you've planted it, you're at 5000 RPM, and nothing's moving apart from the engine, and it's trying to turn the differential, but it's being prevented from turning because the wheels are still gripping on the ground. That is the time when the maximum torque will be applied to the system. So you've got 1500 Newton meters trying to do that, and you've got 4700 Newton meters trying to do that. The 4700 Newton meters is twisting the beam like this, and the 1500 Newton meters is trying to twist the beam like that, and you've got a combined equivalence that is doing that. It's trying to dip the rear quarter of the beam, and I think the resultant is that this bolt hole is trying to force itself towards the ground, and this bolt hole is going up the way, but they're both going down. So it's trying to twist itself. And what I think it's going to do, it's going to go like that. It's going to try and do that. Okay, I'll put a bit of twist in here, and I'm holding this end still. So I'll do that. That's how I think the beam's going to go. Yeah. And that's what the material inside the M beam is trying to prevent. It's adding the equivalent of 2mm of steel all round this area, all round the bottom half of the beam. There's the equivalent of 2mm of steel being added to the beam to prevent that from happening.